Hello, everyone. It's so wonderful to have you all here today. It is my great pleasure to introduce two of my favorite people to talk about this really timely topic. Matin from Generation Lab and Moshe from CivicSync. The title, as you see on the slide, is about RAGs and LLMs turning AI into real intelligence for public opinion research. I've had the pleasure of working with them for the last few months, and you have a very exciting presentation ahead. They will also be at WAPOR and APOR next month. So if you'd like to meet them in person and have more detailed discussions, you will be able to see them there as well. So without further delay, turning it over to the both of you. Very excited to have you both here. Thank you so much for joining us.
Thank you, Alice, and thank you to WAPOR for hosting this webinar. We're grateful for the opportunity. We're excited to be presenting today, and obviously would love to continue the conversations virtually or in person at WAPOR and APOR. So as Alice mentioned, my name is Matin. I'm the COO and co-founder at Generation Lab, and my dear friend Moshe Borouchov, he is the CEO and founder of CivicSync. To kind of set the stage, I'll be going over some of the implications and use cases of RAGs and LLMs when it comes to survey research. I'll try to limit the amount of hysteria. I'll introduce the conversation, and then Moshe hopefully will take it on from there and provide you with a lot of kind of excitement and hope and opportunities to leverage these new tools in new ways beyond survey research when it comes to understanding public opinion research. Great. I'll start off by kind of going over some of the opportunities that there are in leveraging LLMs for survey research. Some of these have been have been discussed in the industry, in our kind of in WAPOR and WAPOR, so I'll be brief. One of the opportunities is that you might already be using is actually in questionnaire design. So this is when it comes to writing questionnaires that are kind of are well designed, that kind of adhere to some of the standards that are out there, kind of coming up with ideas. You can kind of you might already be using this. You can easily imagine how you can interact with an LLMs in natural language, and it will help you write questionnaires faster, and they might even help you think about developing better questionnaires and getting into more details. Another opportunity that's a little, I think, less discussed in public opinion research, but I think there are a lot of interesting lessons that we can take away from psychometrics, is actually developing adaptable questionnaires. So there's a lot of literature in our own kind of field and in the field of psychometrics that when it comes to, the way questions are framed really have an impact on the responses on the and obviously in the field of psychometrics, when you're assessing someone's perhaps knowledge, you can imagine if someone if a question is framed in a context that's not familiar to them, it can reduce their ability to provide a good response. And people are already incorporating LLMs into providing standardized but context-specific questions for that purpose. I would argue that the stakes are even a little bit higher of measuring things right and standardizing those in the field of psychometrics and in the field of public opinion. And I can see how we would take away those lessons and try to come up with adaptable questionnaires that are standardized across the board using LLMs. Another area that you might already be using is understanding open-ended responses, particularly when it comes to transcription or analyzing, audio and video using multimodal models. instead of having to kind of go through and listen to, or code a lot of responses. This is being facilitated by an LLM. The WAPOR had a webinar in April, I believe, from the researchers at the NORC at the University of Chicago. I would highly recommend it. They talk this in much more depth than I am, and provide you with some really interesting results and guidelines and guidance in terms of how to incorporate that into your own research. Another use case is, and Moshe will discuss this a little bit in another context, is threading dispersed data points. So you can imagine if you have a panel of respondents that have been surveyed over time, they've provided input across a variety of different surveys, across a variety of different topics. And so you have this kind of really rich pool of data that you can derive insights from. In a pre-LLM age, the way you would go about, really, if you had like a major question that you wanted to answer using this pool of responses, the way you would go about that is go through all the surveys, try to find relevant questions, try to find who has answered to which of those questions, and really, piece by piece, get these together and try to find an underlying trend or result. Now with using LLMs, going through that mass of data at both the individual response level is much easier. You can really see how now you can access this kind of massive pool of data, trim it down to the pieces that are really relevant to that specific question that you want to answer, and you can thread together all these kinds of data points that are kind of spread out and put them together in a coherent format. Another opportunity, again, the other kind of webinar really touched on this, is thinking about personalized messages to improve response rates. We're obviously really dealing with difficulties when it comes to response rates across the board to surveys, and every little bit that we can improve that, it would be helpful. So we can imagine similar to the way we would provide an adaptable questionnaire, we would provide an adaptable survey invite, empowerment invite, where we would really customize the messaging to a context and to a topic that's familiar to people and resonates with them to improve that. Great. Next slide, please. And this is kind of and you can play this. Thank you. So this is kind of in line with what I've already touched on a little bit. Obviously coding data. I am very familiar as a COO with kind of the grunt work of survey operations, as I'm sure a lot of people are here too. And this will kind of help with facilitating some of that work. Obviously, coding data that we already touched on. There are already tools. There's a startup that was recently launched that allows people to turn survey from natural language into a formatted program survey that you can obviously check and verify. But it is definitely trimming down a lot of the kind of the operational time and resources and costs associated with just going through programming the survey, going through the flow. Another example here is actually testing surveys. So you might have a survey that actually has a lot of different flows. So in our case, an example could be a survey that's tailored toward young people, which is our specialty, but you want a different questionnaire for people who have gone to college, that is different from people who have never been to college, or can be different from people who are in the workforce. And for you, you would really want to make sure that that each survey flow is actually working well for you and is responsive. And this is a huge kind of part of quality check. So about a year ago, we actually developed an internal tool that allows us to provide a persona that would be the survey taker for us, and have a test. We have this testing tool that essentially fills out the survey as if it is that persona. So The key here is that it would go through the survey flow consistent with the persona that we introduced at the beginning. If you kind of look back later on, or if you have been looking at the questions and the responses that are being provided, they're all consistent with one persona. And that will allow us to go through the survey and not kind of be captured by some of like the traditional ways that we have kind of impediments that we would put to capture traditional bots, right? Now, as I've mentioned this, you might be thinking, well, this is a great tool for, as someone who wants to commit survey fraud. And obviously that's a huge challenge for us. So I think it's a great segue to that. And I will say that you might not be the only person who has thought about this. So if we could go to the next slide. We obviously developed this about a year ago, but just a couple of months ago, just 3 months ago now, OpenAI launched what it's calling the operator, which is essentially a browser-based tool that can perform tasks for you as a human would on their browser, right? And when this was introduced, a couple of reporters on the New York Times Hard Fork podcast discussed their pilot ways of using this tool. And one of the first things one of the reporters tried was actually having the operator sign up for a survey panel and complete surveys as a human to make money. And they were actually able to make money from this, circumventing all the checks that might have been in place to prevent fraud. And yes, if you read through, you can see that it's not, it's actually, it took it 45 minutes. It earned $1.20, which is, depending on how you look at it, a lot or very little. It probably took a lot of resources from OpenAI. I don't know if they would like that, but at the end of the day, this is a general use case tool. You can imagine a tool that we developed that internally for testing purposes being developed for this purpose and used in a malicious way that is for the specific use case, that is using more efficient models. So the costs are much lower than what you're seeing here. So I think we have to really start thinking about this problem kind of beyond thinking about this problem seriously, regardless of what the kind of like this the pilot experiment might have looked like on this podcast. So go to the next slide. And I'll kind of talk about why this is happening a little bit and the challenges that LLMs are posing to survey research. So, some of the traditional fraud detection measures that you have seen, that you have incorporated probably, that you still might incorporate in your research are, red herrings, looking out for inconsistencies in responses, looking for speeding, looking for incoherent open-end, or using captchas. Well, now we know that with AI-generated responses, as I demonstrated to you, first of all, they can easily find the red herrings. They can provide you with very consistent responses. They don't have to speed. They're not human. You can easily imagine a world where you're introducing randomized intervals that are proportional to the length of the question to prevent speeding. You can as you probably already can imagine, the LLMs can provide you with very, very coherent open-ended responses. Yes, they can be in a very in a language that can be easier to detect, but obviously that also is something where you can prompt the LLMs to not sound like an LLM, and it would try to really kind of tailor the response in a way that's really hard to detect. I know people are working on AI detection tools, but I don't know how successful we are in that realm. And captchas, there's actually a paper that really shows that some of the existing tools in the market that are commonly used are circumventable using new LLM models. So really a lot of kind of the traditional fraud detection measures that we have used, unfortunately, won't work anymore or are currently not working. So, I gave you all this context and, so let's think, you might be expecting that we can address this, and I will. But if we go to the next slide, I think for those of you who might not be familiar with the different stages of grief, I think when we think about survey research in the age of LLM, I think we are saying kind of we are moving forward from a different kind of age in the world of survey research, and I think we need to think about the time we're in, how we can adapt, how we can address the challenges, and then move on. So, I think I will provide some answers to those, to kind of some of those to fraud prevention methods. Hopefully, we can bargain together through those. But later on, I think we should also all be thinking about ways to incorporate these and think about what these technologies unlock. And we'll get to that section. Moshe will talk about that, and I think we'll get everyone to acceptance. So that should be exciting. But more concretely, if we go to the next slide, the ways, I think one of the key things that we should think about when it comes to doing survey research in the age of LLM, specifically when it comes to at least making sure we're getting responses from real respondents that are, that we can attach a response to a real human respondent, is really taking lessons from some of the industries that have been dealing with a lot of fraud for years and years. And, this is, areas like banking and cybersecurity. And, there is this concept of KYC in the banking and financing world, knowing your customer, that I think we can adapt for using in survey research. And I would, I would say we also should know our participants in KYP, if you might want to call that. And it doesn't have to be as rigorous as banking. Obviously, the stakes are different. Our threat models are different. But here are some of the tools that we have leveraged, and I think some of the tools that you can think about leveraging depending on the context of the surveys you're doing, depending on the types of studies you're using, and see if they work well for you. So one tool that we can really leverage is IP addresses. IP addresses are manipulable, but also they are governed by some specific conventions that we can use. So for example, IP addresses for data centers, which can be a source of automated fraud, they have a different IP set than IPs from individuals and residential areas. And VPN servers have a different IP. So using IPs is one way for us to really leverage those conventions to uncover more information about a respondent. So I don't think the right approach is necessarily that we remove any respondent who's using a VPN, whose traffic is going through a data center. But I think we should take that into account. We should use proper and additional vetting for those responses. Another kind of vector that we can use is actually phone numbers. And again, what I will talk about is very much relevant to our experience as a US-based company. And I am very much aware that some of these tools might not be available, might not work well in other contexts. So I definitely want to admit that this is from our experience. I hope there are kind of applications across the board, but I also recognize that there might be kind of gaps here and there. But back to the phone numbers, I think one thing that happens for a person who obtains a phone number, there is an identity verification process embedded in that process for someone to acquire a phone number, at least in the US. So we can leverage that. So by looking at making sure a respondent, a panelist has a phone number, has that they possess, we can know that that person has had to gone through some form of ID verification. Now, obviously, the requirements for voice over IP phone numbers are much more relaxed. So I think knowing if a phone number is coming in, there are APIs that you can use to flag respondents that are using voice over IP. Again, I'm not saying every respondent that is using a voice over IP number is fraudulent, but I think it can invite more vetting, and it can kind of be another layer that you would use. Then there are third-party identity verification tools. And I will say, if you're using a sample that is from an address-based sample, for example, that can be one layer that you have used. Someone has had a data source that determines that this is a regular phone number, that this is a regular address, and an individual lives there. I think that can be also a point of reference, or if you have kind of sent an individualized invitation through mail, I think that already kind of takes care of a lot of these things. In place of that, if you are using kind of more open non-probability sample out there, you might want to do some validation with a third-party identity provider. These are also same providers that banking services and financial services use. So there is some kind of developments that have already occurred that we can take advantage of. This tends to happen with either data or documentation. Again, this is, there is going to be a trade-off here where you might lose some respondents, but I think depending on the context, this might be appropriate. Then, they can also think about ways to reduce the incentives for fraud. So if you're providing localized rewards, if you're providing rewards that won't be, aren't really useful beyond like one person, those are some ways to kind of think about mitigating fraud. There are camera-based verification processes. So for example, these can be particularly useful when it comes to validating demographics. Again, they're not going to be perfect, especially if you're using them for, for things, for if your range is limited. So for us, when we're focused on younger audiences, these tools will provide you with a probabilistic response, or will provide you with a range, and it's kind of these are more useful at a broader range than a smaller range, but again, it can be another tool in your toolbox when it comes to omitting fraud. But I think using these principles and principles beyond those, if you have ideas, please let me know. I think we should move toward actually knowing the respondent and knowing the participant, then in order for us to be able to move forward, and recognizing that if a form of fraud can be committed, that we need to close that vector and just not assume that, okay, well, it's too hard or it's too much, that it won't be, because people who have the incentives will find better ways of doing it. So if we go to the next slide, now I think another thing that we have to really understand is that just because we know our participants, that doesn't mean that our participants are not using LLMs or AI. There are a lot of cases where it would be almost impossible for us to really tell if someone is using AI or not. If you really, and I think that's something that we have to be prepared to incorporate into our standards, but also try to kind of in order to really kind of have a framework of dealing with it. So in my mind, knowing that anyone can use AI assistant in responses, would really kind of end up having to either assume that people will use AI assisted responses and prepare for it, or what are some contexts where we know for a fact that people won't be using AI assistants, and those would be almost like having a proctored data collection. You can imagine a live interview, and I think then we get back to the idea of really we need to kind of have some ways to standardize the interviews. We need some obviously that also comes with some benefits because then we can have those adaptable questionnaires. We can use a secure survey platform. I will say, as I'm talking about this, there are already people who have come up with ways to circumvent this. There are currently job interviews that people are having trouble with, proctoring proper vetting, and they're enforcing in-person interviews. So I think this is also a very, the solutions I'm talking about today might not be applicable in a month. So keep that in mind. And then beyond that, it really comes down to us recognizing that even when we know our participant, how do we come to terms with the fact that they might use AI-assisted responses, especially if we are doing interviews digitally? So I think this will require us developing standards of thinking, okay, what are questions that we are okay with people providing AI-assisted responses from? When are they helpful and when are they harmful? I can imagine a lot of scenarios when we are providing, when people are providing behavioral data where that would be helpful, that might be even more accurate. I can imagine this scenario where it is perhaps touching on sentiment, and the model is hallucinating, and if a person is not actually, if the participant is actually not being assisted, but rather is just being replaced by an AI model, then we can't really rely on those questions. And then again, I think it will be, we really also need to be able to, in coming into terms with that, we really also need to see how the human is assisted by the AI. So is this, a personalized agent that someone is using to provide responses, or is this actually a person who is just providing you with their own answers that are vetting answers provided by their personalized agents, or is this like completely synthetic data that, again, the agent is hallucinating? So really, I think when it comes to using human-based AI responses or AI-assisted human responses, we really need to kind of look at the pipeline and see where's the data coming from. Is the data grounded on an actual real fact, a real thing? And I think that will be key. And I think this is a great segue to what Moshe will be talking about. I'm really excited, so I'll pass it on to Moshe.
Thank you so much, Matin, for this overview about LLMs and AIs and the different challenges. And I would like to start with a small video. So it's a segment from a satirical comedy that is called Checkout. Kochava, which is the blonde lady that you can see on the screen, is a personal hero of mine. She's a cashier, and she worked in a suburban supermarket, and she have developed a really rigorous technique, almost a scientific method, to predict how each customer would vote. So she looks at the different products that they buy. It's hilarious, it's really funny, and I'm just gonna hit play.
לפי מה את לוקמת? מה זאת אומרת? לפי השיטה הכי מדויקת בארץ. המוצרים של הלקוח. כן, כל לקוח שמגיע אליי, אני רואה מה הוא קונה, לפי זה אני יודעת מה הוא הולך להצביע. אצלי זה מדעי. לא פוקס, גם לא קמיל. וואלה, אז איך זה עובד בדיוק? בוא אני אראה לך. מלפפון חמוץ, תערובת חמוצים, חמצוצים, חומץ, מרץ. הודו, נקבה. רובית, גני בוקר ציפי עם הסנאית ושוקולדה. מרב מיכאלה. בפלות, במבות, שוקולדים. טוב, זה קל. עלי ירוק. מה, לפי מה את לוקמת? מה זאת אומרת?
Okay, let's move to the next slide. So Kochava, I hope you fell in love with Kochava as much as I love Kochava, but Kochava is not the first person to come up with this political psychic game. Back in 2020, the New York Times created an interactive quiz that went quite viral. So readers were presented with fridges that belonged to Biden supporters or Trump supporters, and they basically needed to guess to who this fridge belongs to. So each fridge had like a subtle story. Some people associated oat milk and kale with a hint to liberal leanings, and other participants associated processed cheese and Bud Lights to more conservative leaning. It is pretty absurd in many ways, but I think it's really revealing about society and how we think about things. So here you can see two rows. The top rows, so both of these rows are the top correctly guessed fridges from the New York Times quiz. And in the top row, you can see fridges that 85% of guesses were right. So there were associated fridges that belong to Trump supporters. And then in the second row, you can see fridges that are associated with Biden supporters. So again, you can see there is some kind of, so each fridge is a stereotype. So it's not just a political affiliation, but it's also how we perceive lifestyle, class, and culture. And so it went, here you can see some of the conclusions of the game. So there were over 176,000 guesses that were made. And overall, readers only matched fridges to political affiliations 52% of the time. That's barely better than flipping a coin. And the high confidence guesses that we saw earlier, it's just a small subset of the most stereotypical fridges. So the ones that were easiest to label for people, but across the full data set, political leanings were far less predictable. So it highlights a really critical point. When we focus only on clear signals, we are really risking overestimating how much we actually understand. So Kochava started with this stance. The New York Times came up with this fridge game. It went viral, so they adapted it and created another version, which is, here you can see this other experiment. They showed people Google Street View images of neighborhoods, and they asked them to guess if these areas, the political leaning of these areas. And overall, readers did pretty well, much better than the fridge experiment, especially with strongly partisan places. So dense urban street spaces are typically Democratic, and open lawns and cul-de-sac are more often Republican. But the real challenge came in the in-between zones. So these are like the competitive suburban precincts where most Americans actually live. So there are some interesting things to be underlined. There is a growing trend. Population density has become a really reliable predictor of partisanship. So it was not the case 60 years ago, and for me personally, it's a really sad trend. And similarly to fridges, there are some exceptions. So if you think about the Hasidic community that is in Brooklyn, they tend to vote red, but it is a urban area. And then on the other hand, you have some rural counties with indigenous reservations, or even if you think about the Black Belt communities, which historically tend to vote blue. So overall, the main takeaway is that the stereotypes, they may help us guess and get some understanding, but they rarely tell the full story. And this is a pretty good segue to an idea that is very dear for me, and it's quite interesting, which is called affective polarization. So it's not just about political disagreement. It fuses unrelated aspects of identity into rigid partisan divisions. So everyday choices, from what you buy or where you live, the car that you drive, grocery store that you shop at, have become political signals. And it is reinforcing tribalism and deepening social divide. And this misattribution of meaning leads to an increased hostility, a resistance to opposing viewpoints, and a breakdown of shared understanding. Talia Jomini-Stroud, which is the writer of the paper that I just quoted, is talking about this idea that is called connective democracy, which aims to recognize and dismantle false associations. And connective democracy seeks to restore meaningful dialogue and encourage cross-group engagement and to rebuild trust across different groups and partisan lines. And it could be interpreted in a positive way. It could also be interpreted in a negative way, but CivicSync really sits on this intersection. Since we live in a world where a lot of our behaviors are clustered into camps, measuring certain aspects of what people do online would help us to better understand what's one's social personal values. And it's mainly because we do live in a polarized information ecosystem. And this is an assumption on which CivicSync, a very strong assumption on which CivicSync is built on. The information bubble and the echo chamber that we live in has the potential to reveal a lot of information about who we are based on different activities that we do, the things that we do on Amazon, the articles that we read in different news outlets. And this is a good segue to the architecture of CivicSync. So what we do at CivicSync, this is like a small chart that explains how it works. So we recruit real human being panelists that install a piece of software that we developed. The software is installed on one of their internet-enabled devices. So it could be a Mac, Windows, Android, iOS. And every time the installation is completely consensual, and the participants are incentivized in a monetary way to turn on the tracker. And when the tracker is on, we collect a plethora of information that is related to their browsing activity. So when they open Amazon and they get a bunch of recommendations, when they buy something, when they read an article, when they get a food delivery from DoorDash, all this information is streamed into CivicSync in its raw form. And then we use AI. And I'm going to delve in a little bit deeper into, it's not going to be, I'm going to explain how we use AI in a very methodological way. But these signals, they have a tendency to be really noisy and really messy. And we leverage AI to take this mass of signals and decipher it, understand what is a strong signal, what is a weak signal, and structure everything nicely in a tabulated format. And then once we have it cleaned, we build on top of it an additional layer, leveraging RAGs and LLMs to create what we like to call a digital twin. And then our clients, which are essentially researchers, when they want to interact with the digital twin, they can connect to the platform, query the subset of the digital twin they're interested in based on demographical information that our participants contributed when they onboarded, and instantaneously they get a response that is really anchored in behaviors that we see and not necessarily on self-reported data that we get from people by filling surveys. So let's have a deeper dive into the underlying technology and how CivicSync works. So how does tracker actually work? So let's start with something simple. Most of the apps on your phone need internet connection to work. So if you open an app and you don't have internet connection, or God forbid you have 3G, you're not going to be able to do much with your phone. Whether it's DoorDash, Netflix, Amazon, or obviously Google Chrome, they're constantly sending and receiving data. We're like just beings walking in the world, radiating signals 24/7. And the absurd about it is that, not the absurd as somebody that is interested in market research is that this data is really rich, it's really dense, but a lot of the times it's not properly tapped into. So it contains subtle behavioral signals, what you are searching for, what content is recommended for you. So when you open Amazon, you get a bunch of recommendations, and all these recommendations are things that Amazon think you might end up buying. And for us, people that do market research, this is a really, really valuable example. And it's the same thing. These recommendation algorithms are present everywhere, and they are really telling and revealing about what interests us. So by passively analyzing all this network traffic, we can build a clearer picture of someone's information environment and ecosystem. And we, as I said earlier, we do not only rely on self-reported questions, we actually look on what's happening into your digital information ecosystem, and based on that, we derive and extract a lot of insights about you. So I talked a lot about network traffic and how it looks like, and it is really abstract. So to make it a little bit more concrete, I brought you here 2 examples. So technically, and I won't go into a lot of details about how it works, but internet traffic is structured through what is called an OSI model. So it's like, if some of you are a little bit technical, there is like this famous 7 network layers of how data moves between devices that are connected to the internet. And there are multiple fields that describe how the data should travel from this point A to point B across the network. There's what you might see if you look, this is what you might see if you look into one of the packets. On the left, you can see a snippet of a single request that was made out of Reddit. And then on the right, you can see another snippet that was made from the New York Times. And at the first glance, it looks like a total chaos. It's a wall of text. It's impossible to read. But if we zoom in, we could see some patterns start to emerge. And beneath this gibberish, there is meaningful behavioral signals that is encoded. So things that the user searched, and what content they viewed, what recommendation they received. And this is the key. Raw traffic might look messy, but with the right tools, it becomes a powerful lens into human behavior. So here I started marking some interesting bits of information that are interesting from the gibberish. If I zoom in a little bit further into the Reddit packet, we can see between all the soup of characters, some structure starts to emerge. So in this snippet, you can see that the user clicked on a post in the Korea subreddit. You can see the post title. So new downloads of DeepSeek suspended in South Korea, Data Protection Agency says. And right next to it, there is also an outbound link to a Reuters article. This is a subset of one network traffic. And we learn not only the content that is being viewed, but also the topic. So this panelist that installed the CivicSync tracker, they're interested in the Korea subreddit. Obviously, they're reading some articles from Reuters. And it's a highly detailed behavioral fingerprint that we can use for our benefit. So I showed you a little bit how raw network traffic looks like, and we did like this kind of a mini exercise where we try to decipher the gibberish to extract some value and insight out of it. But the really challenging thing with network traffic is that every packet has a different latent structure. The data is messy, it's unstructured, and there is a very high level of variability across platforms. And our goal is to extract meaningful insights out of it, like what someone read, like we've seen before, things that they searched, things that they clicked on, without knowing in advance what app they're using or how the data is formatted. One obvious solution is to go to the manual route, and companies that are doing behavioral signal analysis, up to recently, they relied on this manual route. You sample the traffic, you identify the most popular services, and then you build a rule-based system to extract the relevant fields, title, links, timestamps. It is a good starting point, especially if you're trying to understand the most of the data that you're collecting. But very quickly, you run into some serious problems. So first problem would be rule-based systems are really fragile. They break. And the moment the service changes or the layout of the API structure moves, it just doesn't work anymore. And we at CivicSync, if we had this approach, we would constantly need to be patching our rule-based system, and it's a lot of maintenance. Second, which is related also to the first one, it does not really scale. So different endpoints and different services serve data in a different way. So the way Netflix serves data to their users is fundamentally different from the way YouTube serves it, and again, very different from how Facebook might serve it to their users. So there is a variation across different apps and also across different endpoints, and maintaining different logic across dozens of platforms becomes a full-time job. And third, there is the problem of the long tail. So even if you identify the critical mass, all those less common services that users interact with remain untreated, and we would never be able to write rules for all of them, even though that's often where the most surprising insights hide. So it means we do need to treat the long tail if we want to extract some meaningful insights and gold nuggets about our panel participants. So this is where there's like a small paradigm shift that happens, and a lot of it is thanks to AI and LLMs. Instead of trying to rigidly and rigorously index everything and write a rule-based system, we need a more flexible and versatile approach, one that can query the traffic dynamically and extract meaning on the fly. So here you can see in the illustration, like the things that I marked earlier, and what you can see here is ideally how we would like to have the data. So extracting the things that are really meaningful and ignoring things that are not necessarily meaningful, like the ID or a lot of gibberish. So how we can deal with, how we can overcome the complexity. So one way to deal with messy, inconsistent traffic across thousands of services is to leverage state-of-the-art language models. So they are already trained on vast amounts of internet data. So as you probably know, LLMs are really good in hovering and swallowing and training across the corpus that is called the internet. So they have the habit of reviewing network traffic, and then instead of reinventing the wheel or hand coding the rules, we prompt these models with clear instructions. So we would pass to the model a snippet that I've showed you earlier, and we would ask, if I simplify it a little bit, what is the article title, what is the source, what is the link, and then the LLM would return us back a structured JSON format with the valuable data that interests us. The response is clean, and we get labeled outputs instantly. And this approach is really powerful, not because we build the models ourselves, but because we know how to orchestrate them and to apply them at scale on real world data in a way that's fast, flexible, and robust. So this is where it all begins. If I go back to the chunk that I showed you earlier, and I'm going to walk you through the process of how we analyze the data. And at the end, I would also demo you the actual tool and how everything is put together. So there would be like a small dip into things that are slightly technical, but it would all get together very fast. So stay with me. So what you're seeing here is a raw packet. And this is like an actual chunk of network traffic that was captured from one of our panelists. Looks like noise, but inside we know there is some interesting data points. What we do, we take this chunk, we divide it into multiple chunks, and then from each chunk, we try to extract the most relevant data. So this is exactly what you can see here. From each chunk, we extract the article title, the article URL, the subreddit, and the data in which the article was published. Sorry, we get it in a JSON format, and this is where the behavioral signal emerges from all the technical chaos. Once we structure the data, we do what is called an embedding, and each interaction, which is a small cute JSON file, is whether it's about Mars, environmental policy, or Korean tech regulation, it gets turned into something that is called a dense vector, which is basically a number on multiple dimensions, and it's a mathematical fingerprint of what the behavior is about. LLMs are really good with reasoning with this kind of format of data, so transforming it into a vector is a really crucial step in our processing pipeline. We then index these vectors, and which essentially means we make them searchable and not by keywords, which is like the typical kind of a Google search that we all love and use on a daily basis, but rather by a semantic meaning. So once we have that all put together, the researchers that use the CivicSync platform can connect. They can ask a question like, what articles did you recently read about Korea? The query, now instead of searching the keywords using rigid filters, the system would take the question, embed the question itself, transform it into a vector that captures the semantic meaning behind the words, and then the vector is used to search through the index of the behavioral data that we collected. So not just the raw events, but the structured insights we've already extracted. So if you remember, the article titles, the subreddits, URL dates, and more. And in this case, we find a match because we already extracted some information about tech regulation in Korea. And we see that the user recently clicked on a Reddit post linking to the Reuters article. And then the system does not just return the behavioral data that supports a potential answer. It takes it, builds a context out of it, feeds it back into an LLM, given the context and the query of the user, and then we get an output that reflects how the user experienced and what he would have answered if he would have gotten this question in real life. So let me show you how it looks on the platform. So here you can see the CivicSync platform. As a researcher, you have access to a digital twin catalog, and it's really easy to filter with the different twins. Let's say I want to start a chat with this twin over here. Sorry, I guess there is a demo curse right now. Let me log back in. Great. I'm just gonna filter so we can do it together. Okay, so let's say we want to have a chat with this twin, and I can easily click on having a chat, and then let's say I'm interested in understanding their behavior when it comes to DoorDash. I click on the question, the twin is prompted, and then immediately I can see all the information about their favorite restaurant. So something that pops quite quickly is the fact that they enjoy $3.75 chicken and fries, Bleecker Street pizza, and then for going back a little bit to the point of Matin and how LLMs could be used, these answers are not just the distributions that we randomly get from the LLM. They're really anchored on real behaviors that we collected from the user. For each of these questions, we can dig in further into the sources that were used to generate the answer. And here I can see that indeed, my human panelist went on DoorDash and ordered large fries from Chicken and Fries. I can see the image. I can also see the price. And it's a really nice way to interact with the different twins. So this is like a kind of a flow that you might want to have, an open-ended flow that you might want to have with a smaller subset of twins. But then again, if you're more interested in having a conversation with multiple twins, you can also have the option to create a chat with multiple twins and submit a poll. So this is a poll that I prepared in advance, and I asked my twins if they go on Walmart, and I can see that one of my twins answered yes, and again, I can see for what reason and why they answered yes. So we really have this kind of iterative approach of asking a question, seeing the sources. In this scenario, I can also prompt another chat with a group of subset of twins that answered a specific way. So if I want to continue with the twins that answered the third question, I can chat with all the non-applicable twins. And then again, it would create another chat where I can keep on digging further and extracting some more insights. So this is the end of the presentation. And if there are any questions, we are more than happy to hear them. So you can either unmute yourself or put it in the chat.
And one thing I'll mention before we go into the Q&A is that you know, one of the key things here will be to really, see how this data really stacks up against real behavior. So one example is, first of all, to ensure that the data that is being captured, the data is being properly captured is, we obviously, there's testing going on to, do a behavior on a device and making sure that it is being captured. So that's on a kind of like closing the loop in terms of the data collection side, but also in terms of comparing that with I think there's some next steps for in the work that at least Generation Lab is doing with Mosh is about looking at self-reported data, comparing that with metered data. Obviously, there might be some discrepancies because people don't remember things. People might misunderstand the question. So I think that will be very interesting. But also looking at sentiment data. Can we actually extract someone, can we interpret someone's and extrapolate someone's political behavior based on their grocery cart? And I'm sure there's going to be, things that are going to be revealing and not so revealing. And, also the questions are going to provide a range of, they're going to vary across, how useful this data is versus, a traditional survey data might be. So let's see, I think, so Moshe, I think you might be able to kind of, and Esther, I'm not sure if you are speaking about, survey research or this kind of the use of LLMs in terms of using more comprehensive data. So Moshe, I think you can speak a little bit about like the aspect of the data collection and the working with very unstructured massive data sets. So for new researchers, what's the best way to learn to do this kind of thing?
Yeah, so I think one of the nice things that is embedded into the data digestion pipeline at CivicSync is that we really try to avoid and have any kind of assumption or prior knowledge about the data that is being streamed into the system. And working in this premise allows us to digest different types of data that are not necessarily network traffic. So one of the areas that we're exploring right now, and it's a really exciting one, is data donation. So there is the data that we can collect when the tracker is on, but there is a lot of rich data that is not necessarily available when the tracker is off, or when we onboard the panelists, we do not necessarily have the historical information of the social media interaction they had in the past. And for that scenarios, our pipeline is definitely capable of handling an export of all the historical activity that you had, like one of the panelists had on Instagram, and push it through the same data pipelines and extract some meaningful insights. So if I do the kind of same metaphor, the projection, this kind of methodology could also work for survey data or self-reported data that has been collected in the past. Obviously, it contains some limitations. So the things that you might want to do in a classical way would not lend themselves properly. And when you try to take the data, create embeddings out of it, and retrieve the most relevant pieces of information. But this is also something, the world of market research is a very, there are different tools to understand people, and surveys is one of them, focus groups are another one, and we will really believe that the CivicSync is a revolutionary tool and an option to explore behavioral data. Because one of the biggest challenges that we have with behavioral data, and it's like kind of the paradox with behavioral data, is that it's really rich on one hand, but on the other hand, it's very complex to decipher and understand what it contains. And this is where Civic Sync really shines. So I wouldn't say the methodology of like the way that we treat data lends itself for all use cases, but we've seen that it works very well on many of them.
And while we're getting more questions, I think one question that I had for you, another question I had for you, Moshe, is, you know, can you talk a little bit about the, that kind of like the semantic meaning aspect of this? Because I think, one example that I've heard about the distinctions between using a natural language processing analysis, and not just in the context of LLMs, was, for example, when someone talks about, feeling sick, it's very different in the context of going to a restaurant versus going to the hospital. So I don't know if that's a good example, but if you can talk about how that embedding really is able to take that kind of like that semantic meaning into account.
Yeah, so I think this is a really interesting example, and I think in many ways this is why large language models are super exciting. So having in a classical retrieval way, usually when you look for a word, you might also try some variations that are in the semantic field to retrieve documents that are relevant. And when you take a word and you transform it, or a piece of text and you transform it into embedding, you basically add a lot of richness that was embedded inside the model during the training into a query. And a lot of the things that are not necessarily captured in a simple search are added into these embedding formats, and topics and ideas that are not necessarily obviously related suddenly become apparent and surface when you use this kind of approach to search for things. So I think there is no like one panacea for like the search problem, but what's really exciting about embedding is that it really introduces a lot of opportunities that were not available before. And coupling it with the option of having an interface that allows researchers to communicate in human language with the digital twins that we're building is almost an obvious solution given how the technology is evolving.
No, thank you so much. That makes a lot of sense. And I think that's the area where I think it is exciting. And, when we think about the future of kind of public opinion research, it's not going to be, just limited to survey research. Obviously, there's a lot of really interesting opportunities that will be opened up thanks to these models. And obviously, there are a lot of challenges to kind of how these things have been done in the past. And obviously there still will be a place for surveys, at least as far as I can tell at the moment, and for a while, and there are going to be use cases. And I think this just gives us more tools to deal with a lot of different scenarios. So I think that's the exciting part. So let's see if there are any other questions. I think we're pretty much good, but Moshe, I don't know if you had any parting thoughts before we wrap this up.
No, just thank you for coming, and feel free, like if it sparked any kind of curiosity or you want to learn more about what we're doing, feel free to reach out, and we'll be more than happy to share more. And yeah, thank you so much.
Amazing. Thank you all so much, and hopefully we'll see you at WAPOR. If not, and for our emails, I think we can send those in the chat. But hopefully we'll see you at WAPOR, and if not, feel free to reach out to us virtually, and I'll put our emails in in the chat. Hopefully I didn't misspell your email, Moshe.
Perfect.
Great. Thanks, everyone.
Thank you.